Hi, welcome to this first lesson in the Tables chapter, Tables Made Easy. We're going to go ahead and demystify tables during this first lesson here, and by the time we're done, I think everybody's going to understand a little bit better what tables are and how they work and how to use them. It seems like it's a slight topic of difficulty for some people, so this is going to be particularly useful for people who are just getting their traction with the action scripting in AutoPlay Media Studio. So I hope everybody goes through these lessons in this chapter and really enjoys them. Okay, let's jump right in. I'm going to go ahead and just display these layers here in Photoshop. This is just a little display presentation I've set up. Okay, so we all sort of understand variables, right? A variable is like an envelope where you can put data in there. One piece of data, basically. So an example of that would be name equals John or x equals 5. Now if I said to you name equals John and then I asked you what is name, you would basically understand to say John. Okay, this is really great for most situations, and basically it accommodates most type of data handling, simple data handling, taking information from forms and so forth, right? But what happens if you want to extend this to be multi-dimensional? So for example, if we have an envelope filled with smaller envelopes, okay? We can't do that with variables, so we need something a little bit more powerful, and that's where tables come in. So an example there might be, instead of saying name equals John, saying student equals, and then name equals John, age equals 30, class equals P31, for example. That's one example. So we're basically containing different pieces of information about that one piece of information. So it's multi-layered data, if you like. Here's another example where we've created a table called date, and then we've inserted different values into different envelopes, if you like, within that table. Okay, so date 1, so the first envelope equals Monday, date 2 equals May, and so forth. Okay, so this is basically just an overview, and it's sort of a simplification, so you don't want to get too bogged down in the details, but that's basically what we're looking at. A variable is like an envelope, and a table is kind of like an envelope filled with envelopes. Okay, so that's an oversimplification of it. Now let's just move along here. If you go to our website on the add-ons page, you see actually that we have a table here which displays the different add-ons for AutoPlay Media Studio, and it gives a different piece of information for each add-on. So for example, here in the horizontal rows we have the title and so forth, and that will be the identifier for that particular element, if you like, within the table. And then on the vertical rows here we have the different subheadings, such as the developer, date, and price. Okay, so what we've basically done here is we've got a table, and the table has different elements, and for each element there's a few different pieces of information, right? So for example, for the calendar object, we've recorded the information for the developer, the date it was released, and the price. And we've done the same thing for each of these plugin objects, and we can basically sort by the different columns and so forth. So this is basically what tables are based on. It's based on a grid, if you like, of data, or a table of data such as you see here. Okay, I'm going to go ahead and move ahead here. Now, I've got a little analogy for that at the bottom here. We've got little envelopes of data flying into a filing cabinet, and we've called the filing cabinet the table. So it's another analogy, another way of visualizing what a table is. Let's go ahead and take a look at some facts about tables. Okay, so the first fact here is a table is just another word for array. They are the exact same thing, and some people also refer to arrays as a hash. Okay, so if you hear somebody say a hash, that's basically somebody usually referring to a three-dimensional array. Okay, so a table and an array are the same thing, and in computer language they're just a grid of data, basically. Okay, so if we go on to the next line here, you'll see here's another example of a simple variable. Student 5 equals Jim. And then here's extending that into a table. Student 5 equals Jim, science 30, 80%. And obviously that's his class and his grade. Okay, so this is what we call a numeric table, and that means it's just got numerically indexed values here. So for example, student 5.1 would equal Jim, student 5.2 would equal science 30, student 5.3 would equal 80%. We've also got a different kind of table called an associative table, and that's this new example I've just put up here, and that's student 5 equals, and then we've got name equals Jim, class equals science 30, grade equals 80%. So we've created value associations within the table here. So we call this an associative table, and that's our second type of table. Okay, so between these two types of tables you can basically find the right one for which type of data handling you're doing. So for example, if we were using a table to describe a rubber ball, we might only need to use a numeric table where we could say rubber ball equals, and then we could say red, bouncy, large, soft, whatever. And in the next instance, it might be more appropriate if we wanted to get really detailed about that rubber ball and say size equals 8 inches in diameter, color equals crimson, and so forth. So depending on what kind of data you need to store about an object or about a particular piece of information, you might choose to use a numeric or an associative table. Okay? And basically the difference is going to be in the way that you access the data and how the data is stored. Okay, so we're going to move along to the next line here, where we show a dialog message box example for AutoPlay Media Studio of array notation, and that's basically retrieving a value from a numeric table. So we've gone here and we've said dialog message box, name is, and then we've got student 5 with the index number of 1. Okay, so we're indexing the first value in the table student 5, which would be Jim, as we can see here. And now here I've got an example of dot notation, and that's basically associated with the second type of table here, the associative table. And you can see here the difference is that we've referred to the value as student 5 dot name, because we've got that value stored into this variable name within the table student 5. So it's just different ways of looking at how you're going to store your data, but the bottom line is it's still very simple. A table is just a container for data, for smaller pieces of data. Now, a table is an interesting kind of container, though, because it can contain different types of data, including other tables and even functions. So you can even write your own actions, and we'll look at that further on in this chapter here. But basically, I hope this has sort of cleared things up a little bit for you. And just to review, we're going to go back to the first bit here, and we'll show this again. The variables being data that you can put into an envelope, such as a single piece of data like name equals John or x equals 5, and the table just being the extension of that, so that we're basically storing more information about the same basic element. So instead of saying name equals Jim, or sorry, we said John there, we're now saying name equals John, age equals 30, class equals P31, and so forth. So it's basically the difference between an envelope or an envelope filled with smaller envelopes. Okay, and the final analogy I'd like to leave you with is this table, because this is what it's based on, and that's just a grid, a very simple grid of information. For example, here we've got the title, the developer, the date, and the price, and then we've got different objects, and with each object we've stored those 4 pieces of data, and we can display them here in a table. So this very much mimics how tables work, where we would create an element for each of these add-ons. For example, add-on 1, add-on 2, add-on 3, add-on 4, and for each element we would store these different pieces of information. Okay, so hopefully that's cleared up a little bit what tables are and how they work, and we're just going to go ahead and jump right in with the next lesson and start